A shoreline in 1498. A small boat bumps onto sand. Sailors bend under a heat that smells of salt and wood smoke. Someone hefts a strange fist-sized object, hairy, round, heavier than it looks. When they crack it open, they find a cup of clear water and white flesh, and 3 dark pits on the shell that to their eyes look like a face. Superstitious laughter. A name is given, one that will travel into European languages. Coco, a word tied to a scarecrow or bogeyman. The thing that feels like a monster on that beach will end up on the shelves of empires. The title is not an overstatement. The Untold Story of Coconuts. How a single plant rode currents and cultures to conquer the tropics. What looks like a humble grocery item carries a far richer biography. Anatomy shaped by the sea, a partnership with ocean-faring peoples, a genome that records human voyages, and a later life as fuel for factories, wars, and global markets. This is a story of drift and design, of usefulness and exploitation, and of how a plant can become a map. If you enjoy surprising history, like and subscribe. To understand why a hairy nut could travel the world, start with the coconut itself. At first glance it is a fruit, the thing you eat or drink at the shore. Botanically, however, it is more precise to think of it as a drupe, a fruit with a hard inner shell protecting the seed. Imagine concentric layers. The outer skin is smooth or slightly waxy. Beneath that is a thick, fibrous husk, the part that traps air and makes drifting possible. Inside the husk sits the hard, woody shell, and inside the shell, the living seed, a thick layer of white endosperm, the coconut meat, and a pocket of liquid, the water. The embryo, the future palm, nests against that meat like a small, patient machine. That husk is the first secret to ocean travel. Its fibers form an insulating mat that holds air and resists soaking. The shell itself is dense and watertight. Together they make a package that can survive weeks or months at sea. In ocean trials and field observations, whole coconuts have been found viable after long periods floating, sometimes more than 3 months. Currents can carry them across hundreds or even thousands of kilometers. Cracked open, the water tastes faintly sweet. Whole, the seed is sealed for a long drift. If a coconut strikes a suitable shore and the interior remains alive, it can germinate into a palm that will seed future generations. But floating is not the whole story. The coconut palm is a specialist for coastal life. Its seeds can tolerate salt spray. Young palms grow in sandy soils where few other trees will take root. Wind and waves will bury detritus, and the palm's extensive root system helps stabilize shifting sands, turning blown beaches into the first steps of an island's terrestrial life. In ecological terms, the coconut is a pioneer species, one of the plants that, given a sliver of sand and a little time, can begin to build a landscape. Those biological gifts make a coconut a natural colonizer, but humans quickly learned to turn those same gifts into tools. For islanders across the Indo-Pacific, the coconut was not mere food. It was a portable toolkit. Water in a sealed coconut was a light, safe reservoir on a canoe. The meat provided calories. The fibrous husk, coir, yielded rope and matting. The leaves were roofing and thatch. The shell became bowls and fuel. The trunk offered building material. Even the flowers could be tapped for sweet sap. In short, the palm was a multi-use kit that reduced the logistic burden of long-distance travel and settlement. So while some coconut palms show evidence of natural dispersal, much of the tree's geographic success seems to owe to deliberate human agency. People who planned voyages and settlement deliberately carried seeds and seedlings in their canoes and ships, planting palm groves near shorelines as they established new homes. Across the Pacific and Indian Oceans, that practice became an intentional strategy. Seeds taken from familiar groves were stowed in shaded holds. Young plants tended during the voyage, and new groves anchored places where food and materials would be reliable in the future. To move a coconut was to carry water, food, shelter, and industry in a single package. Who were these people? Scholars argue for a broad cultural phenomenon of ocean-going mariners who spread people, plants, and languages across vast distances. Some accounts use the term Aranesians, often rendered in scholarly literature as Austronesians, a label for seafaring communities whose navigators pushed from island Southeast Asia into the far Pacific and westward into the Indian Ocean. These were not accidental castaways. Their outrigger canoes, double-hulled vessels, and navigational techniques allowed purposeful voyages spanning progressively greater distances. They took crops with them, taro, breadfruit, yams, and they took the coconut, recognizing it as a seed that could make an island livable. The cultural practices around the palm deepened its role. In many island societies, groves were more than food sources. They were social infrastructure. Coconut trees marked boundaries, were planted at the edge of newly cleared gardens, and featured in ritual life. A mother might plant a seedling when a child was born. A family building a house would plant palms to stabilize the yard and supply thatch. The movement of coconuts thus accompanied kinship networks, voyaging routes, and the slow spread of language and ritual. The interplay of plant biology and human intention left a lasting record, not just in groves and place names, but in DNA. In the early 21st century, geneticists began to read that record. A comprehensive survey published in 2011, led by plant scientists including Kenneth Olson, compared genetic markers across coconut populations sampled from locations around the Indian and Pacific Oceans. The results were striking. Rather than a single uniform population radiating outward, genetic diversity clustered into at least two major lineages, one strongly associated with the Pacific Basin and another across the Indian Ocean and western tropical regions. Those patterns suggest that coconuts were domesticated and moved in more than one pathway, and that human-mediated transport shaped their current distribution. The logic of genetic inference is simple to grasp. Populations that have lived in place for longer tend to accumulate greater genetic variation. Areas with the deepest diversity are often the places where a species first diversified or was first domesticated. In the case of the coconut, higher genetic diversity in parts of island Southeast Asia points toward an origin there, the central Indo-Pacific, rather than in the distant Indian Ocean or on the shores where Europeans first encountered the palm. The two-lineage pattern implies separate centers of cultivation or long-term human management, and the specific genetic links scored in places as distant as Madagascar hint at maritime connections that predate European imperial voyages. Madagascar offers one of the most evocative threads in this genetic tapestry. On that island, coconuts and other cultural markers reflect an apparent connection to Southeast Asia rather than to mainland Africa alone. Genetic samples from Malagasy coconut populations show affinities with Southeast Asian palms, a clue consistent with linguistic and archaeological evidence that people from the far reaches of the Indonesian archipelago reached Madagascar centuries before European contact. Put simply, the coconut carries the memory of those voyages in its genes. All of this reshapes how we think of the coconut's discovery by Europeans. The fruit was not a newly arrived curiosity in 1498. It had been moving across the surface of the planet for millennia, and communities around ocean basins had established sophisticated relationships with it long before a Portuguese landing party gave it a European name. That realization reframes the image of the medieval beach scene. The sailors were encountering a familiar tropical technology, not the origin point of a global story. Yet the genetic picture is complex and qualified. Studies like Olson's provide strong evidence for distinct lineages and probable human influence, but they do not yield a single, simple narrative. The agricultural history of coconuts likely includes episodes of natural drift, deliberate transport, local cultivation, and selective propagation over many centuries. Researchers caution against reading the DNA as a straightforward travelogue. Rather, it is a palimpsest, with overlapping traces of natural dispersal and deliberate human choice. Still, the broad message is clear. Coconuts do more than float. They record. That archive in living tissue has practical implications. For anthropologists, linguists, and historians, plant genetics has become a tool to reconstruct migration paths where written records are silent. Where a language family spreads, the plants that accompanied its speakers often show parallel patterns. In this way, a coconut palm is not merely a crop, it is a witness. The palm's witness extends beyond genetic markers to material culture. The fibers of the husk, quaya, tell of maritime craft because they were used in rope and matting essential for building and repairing boats. The shape and size of fruits chosen for transport may reflect human selection for traits that improve storage, buoyancy, or germination after transport. Over generations, those choices can change the plants themselves, favoring varieties that travel well and that supply more edible meat or sweeter water. Human taste and utility have been an invisible hand-guiding palm evolution. But human involvement also meant the palm could be enlisted into human economies beyond the island garden. As trade networks expanded, coconuts moved into exchange systems, not just as seeds for planting, but as commodities. And here the story bends toward modernity. The same properties that made coconuts valuable to islanders, oil-rich meat, durable shell, versatile fibers, would later attract the attention of distant markets shaped by industrial technology. Before those later chapters unfold, it is worth lingering on a few particulars of form and function. The coconut's water is an endosperm in a liquid state, a rare occurrence in mature seeds. This liquid is nutritionally simple but hydrating. The white meat is a dense store of fats and carbohydrates, making the seed a compact energy source. The shell, once hollowed, becomes a container. Once burned, it becomes a charcoal fuel. The husk fibers resist rot and hold together under tension, qualities that make coir a durable material for ropes exposed to salt water. Every part of the palm serves a purpose. That is why it became so central to coastal lifeways. Those uses are not abstractions. Across island communities, the coconut contributes to everyday survival in concrete ways. In shoreline economies, a grove means a steady supply of building material, food, and cash when necessary. In periods of scarcity, coconuts can be a fallback crop. That reliability helps explain why people invested effort in moving and planting palms. They were planting resilience. And yet resilience has its limits. Natural drift can colonize remote atolls, but human planting reproduces palms in clustered groves that serve communities. When winds, disease, or human action change those groves, local ecologies and livelihoods shift with them. Later historical episodes would make that dynamic far more fraught. As coconuts moved from subsistence networks into colonial commodity systems, the social and environmental calculus of planting a palm took on new meanings. For now, however, the narrative has reached a clear reveal. Coconuts are both engineered by the sea and shaped by people. They floated, yes, but they were also carried in the belly of canoes and the hands of settlers. Their genomes preserve the imprint of multiple pathways across the ocean. Their presence in Madagascar, in the remote atolls of the Pacific, and along tropical coasts is not a single miracle of drift. It is a shared history of biological possibilities and human choices. That duality, natural potential and human intention, makes the coconut a unique source of evidence for understanding how the tropics were peopled and how cultures adapted to life on water. It also sets the stage for the next turn in its biography, the moment when distant industrializing powers and emerging global markets began to see the palm not as a local utility, but as a source of raw material for factories, cosmetics, and warfare. What happens when a tree that once supplied subsistence and social meaning becomes a commodity extracted at scale? How did plantation systems reorder landscapes and labor? And how did the palm's role in island cultures change when the value of coconut oil rose in European markets? Those are questions that belong to later chapters, after the age of small canoes and genetic revelations. But already, the arc of the story is visible. A movement from local ingenuity to global demand, from a seed's drift to an empire's logistics. The coconut's voyage, physical, cultural, and economic, is not yet complete. Europe's first recorded European encounters with the palm arrive like an echo of that beach scene. Marco Polo wrote of a tree which bears a nut that is as big as a man's head, and later Portuguese sailors in 1498, part of Vasco da Gama's circle of voyages around the Cape, stood on unfamiliar sands and lifted that same hairy sphere. To their eyes, the three eyes in the shell read as a face. To their tongues, the sight demanded a name. Coco, tied to a bogeyman in Iberian folk speech, became the label that would travel into European languages, carrying with it a quiet erasure of the longer histories already embedded in groves and soil. Europeans catalogued and classified the palm, Linnaeus later placing it in botanical order, but the plant those sailors encountered had already been moving in human hands and currents for millennia. The arrival of Europeans did change the coconut's trajectory, though not by introducing it to the tropics, rather by reorienting the palm toward global commodity chains. Beginning in the early modern period and accelerating across the 19th century, industrializing Europe and later North America discovered economic uses for coconut that went far beyond island subsistence. Copra, the dried white kernel of the coconut used to extract oil, became a key raw material. Coconut oil found markets in soap making, margarine, candles, and later in cosmetics and industrial lubricants. Processing technologies and refrigeration made it possible to ship coconut-derived products across oceans. A palm that once supplied local needs now supplied factory lines. The economic logic was straightforward. Palms produced a durable store of fat, and fat was valuable in markets hungry for cheap vegetable oil. European firms moved to secure supply. The Lever brothers, William and James, whose Sunlight soap brand helped found what would become Unilever, are a prominent example of the corporate impulse that followed. Seeking steady, controllable inputs for large-scale soap production, such companies pursued integration, owning plantations, investing in processing facilities, and arranging shipping networks. Vertical integration promised security of supply and profit, and plantations extended into colonial territories where local labor could be enlisted or coerced into large-scale production. That expansion into plantations was not neutral or benign. Across the tropical belt, from the Philippines and parts of the Solomon Islands to Samoa and Madagascar, land that had been managed in mixed-use gardens, communal groves, and household plots was sometimes reconfigured to maximize corporate output. Colonial administrations and planters imposed new property regimes, taxes payable in cash or in kind, and labor demands that altered social relations. In some places, families found their groves expropriated or sidelined to make room for monocultural plantations. In others, labor was recruited under terms that ranged from wage labor to systems that were effectively coercive. Where plantations dominated, the palm's role shifted from household resilience to export commodity, and with that shift came vulnerability. Global prices fluctuated, and communities that had become dependent on corporate income found themselves exposed to distant market shocks. The human consequences were complex. Some inhabitants derived cash income and new employment options, however precarious. Others faced dispossession, reduced access to land, or labor regimes that eroded customary social protections. Plantation managers imported or encouraged new labor regimes, contract laborers in some archipelagos, taxes in others, with consequences that varied regionally but were rarely neutral. The palm's transformation into a commodity intensified pre-existing inequalities and created new dependencies, even as it tied small tropical islands into the circuits of an expanding global economy. Industrial demand also reshaped how coconuts were processed. Copra production requires drying the white meat to reduce moisture before pressing for oil. Sun drying on racks, smoke drying, and more mechanized kilns were used, sometimes by hundreds of smallholders selling dried kernels to middlemen, sometimes on the plantations themselves where centralized operations controlled both production and export. Price volatility in copra markets, driven by supply gluts, declines, or competition from other vegetable oils, could reduce incomes overnight. For many smallholder farmers, cash from copra sales was intermittent, and the low margin of dried coconut made diversification an economic necessity. Wartime needs temporarily intensified the coconut's industrial importance. During the first half of the 20th century, as Europe and North America geared up for large-scale conflict, the chemical properties of coconut oil gained strategic attention. Vegetable oils can be processed to yield glycerin, an ingredient with multiple uses in explosives and other wartime chemistry. In the Pacific theater especially, coconut-based glycerin was valuable because other sources of suitable oil were constrained. Governments and industrial planners therefore viewed coconut oil as a strategic raw material, and supply concerns affected military planning and colonial administration. Those wartime stories generated striking anecdotes. In the chaos of battle and across remote islands, there are accounts, some well attested, others more fragmentary, of soldiers and medics improvising with what was at hand. Coconut water, sterile inside a sealed nut, was sometimes used in emergency situations where no saline or medical fluids were available. Reports from the Pacific Islands during World War II record instances where coconut water was employed as a makeshift rehydration fluid. But it's essential to be precise. These are improvisations born of desperate circumstances, not endorsements of a medical standard. Coconut water's electrolyte composition differs from physiologic saline and intravenous solutions formulated for clinical use. While coconut water may be hydrating by mouth and has been used in dire emergencies when no other option existed, modern medical consensus treats such uses as limited and non-standard. Any historical anecdote about coconut water in wartime should be framed with that scientific caveat: remarkable improvisations, not routine medical practice. The post-war era brought more changes. In many former colonies, the end of formal empire did not end the global appetite for coconut products, but markets shifted and competition grew. Synthetic alternatives, changes in dietary fashions, and fluctuations in processing technology reduced copra's relative importance in some regions. In others, copra markets remained central to rural livelihoods. The mid to late 20th century saw waves of consolidation in processing, variable government policies on agriculture and export, and sometimes well-intentioned development programs that sought to raise yields through new planting schemes or technical assistance. Yet structural problems, aging groves, lack of investment in local processing, and continued market volatility left many coconut-producing communities economically fragile. Then came a surprising reinvention in the early 21st century. Coconut products returned to global consumer consciousness, not as raw copra, but as branded wellness and lifestyle goods. Coconut oil began to be marketed aggressively as a superfood in some circles, prized in cooking and cosmetics for its saturated fat profile and purported health benefits, claims that have generated debate and that in some cases outpaced scientific evidence. More dramatically, bottled coconut water emerged as a commercial phenomenon. Marketing campaigns presented it as a natural source of electrolytes, a hydrating alternative to sugary drinks, and a fit accessory for a health-conscious urban consumer. These products commanded premium retail prices and created new demand patterns, with whole new value chains connecting small tropical groves to supermarket coolers in cities thousands of miles away. The resurgence brought opportunities and pitfalls. For some smallholders, the coconut water boom and demand for fresh nuts for processing led to improved incomes and new investment in orchards and drying facilities. For others, the benefits were captured by middlemen and processors who controlled market access, or by investors who consolidated processing operations in convenient locations, leaving growers with thin margins. The rise of value-added processing, bottling, dehydrating, producing virgin coconut oil, offered a potential path to more local retention of value, but it required capital, skills, and infrastructure that are unevenly distributed. Where local cooperatives or supportive policies helped farmers gain a larger share of processing or branding, communities benefited more. Where processing remained concentrated in distant hands, the old dependency patterns persisted. Today, production is concentrated but diverse. Major coconut-producing countries include Indonesia, the Philippines, and India, alongside other important producers such as Sri Lanka, Vietnam, and nations across the Pacific. Tens of millions of people, many of them smallholder farmers, depend in part on the palm for food, fiber, and income. Production statistics shift from year to year with weather, disease, and market demand, but the structural picture is consistent. Coconut agriculture is overwhelmingly small-scale, and those who depend on it are often vulnerable to forces beyond their control. Environmental threats add another layer of uncertainty. Coconut palms are long-lived but not immortal. In many producing regions, groves planted decades ago have aged. Yields fall as palms senesce, and replanting requires resources and time. Diseases and pests, some with familiar names such as lethal yellowing, which has had devastating impacts in parts of the Caribbean, or the spread of invasive beetles in Pacific islands, pose real risks. Climate change compounds these biological pressures. Sea level rise, salt intrusion into coastal soils, and increasingly intense storms threaten shoreline groves where coconuts have historically thrived. A palm planted for a child's future may find itself in a coastline reshaped by rising seas or battered by cyclones. Meanwhile, demographic shifts, youth migration to cities in search of alternate employment, leave groves without labor or local management, accelerating aging and decline. The social response to these challenges is varied. In some places, governments and NGOs have promoted replanting programs using improved varieties that promise higher yields or disease resistance, while encouraging agroforestry practices that mix coconuts with other cash and food crops to reduce risk. Community cooperatives and small-scale processing initiatives have sought to capture more value locally, producing bottled water, virgin oil, desiccated coconut, and coir products for export or domestic markets. Crop insurance schemes, where they exist, remain limited, and access to capital is often the bottleneck for smallholders wishing to modernize. There is also innovation at the global market level. Demand for sustainable sourcing and traceability is rising among consumers in wealthy markets, creating incentives, if imperfect, for certification schemes, fair trade arrangements, and direct-to-consumer branding that link origin communities with buyers. Ethical sourcing can improve returns for producers, but certification introduces costs and bureaucratic hurdles that can exclude the most vulnerable growers if support mechanisms are not in place. Technological interventions, mobile-based market information, small-scale cold chains for fresh nut transport, better drying technology, promise modest improvements, but they require sustained investment and training. Seen from a longer arc, the coconut's modern dilemmas reflect recurring themes in its history. The palm's extraordinary utility made it a staple of coastal lifeways. Its oil and fiber made it a target of industrial demand. Each transformation, natural drift to human transport, household use to plantation commodity, wartime necessity to wellness fad, has reconfigured the relationships between people, land, and markets. The palm has offered resilience to small-scale economies while also making them legible to distant capital. Where that legibility has produced investment with local partnership and respect for customary rights, results may be positive. Where it produced expropriation and extractive regimes, the consequences have been painful and long-lasting. If there is a single metaphor that the coconut invites, it is this: a small, sealed package that holds both nourishment and history. Its husk and shell keep time. Its genetic code archives routes of movement. From the central Indo-Pacific genetic diversity that points to an origin region, through the traces of Southeast Asian palms on distant Madagascar, to the clusters of lineage that map Pacific and Indian Ocean pathways, the coconut's DNA is a living manuscript of human voyages and choices. Scientists like Kenneth Olson and colleagues have helped unlock chapters of that manuscript. On-screen citations and careful reading of their 2011 work and subsequent studies allow us to place coconut genes alongside language, pottery, and oral history as tools for reconstructing human movement. And yet the palm resists simple narratives. DNA suggests multiple domestications or long-term human management in different places. Cultural practices vary widely, markets rise and fall, and ecological contingencies, storms, disease, coastal erosion, rewrite local possibilities. Naming the coconut in 1498 was an act of encounter, but that encounter did not begin the palm's story. The coconut had been, for thousands of years, a mobile technology, planted and prized by island peoples who understood its value in ways that European actors either overlooked or reframed within new economic logics. In the present moment, the coconut looks both backward and forward. It is a species with a deep biological capacity to colonize coasts. It is a cultural artifact, planted with ritual and care. It is a commodity extracted and processed at industrial scale. And it is a resilient strategy vulnerable to the very forces, global markets, climate change, demographic shifts, that make modern life uncertain. The challenge, if there is one, is to reckon with that complexity, to value the palm's role in sustaining livelihoods and culture while confronting the inequities and ecological threats that have accompanied its globalization. So when you next encounter a coconut, whether it's a whole nut on a sandy table, a chilled bottle of coconut water in a refrigerated aisle, or a jar of oil on a kitchen shelf, remember that you are holding an object whose biography is longer and stranger than it appears. It is both a drift seed and a carried seed, a wild agent and a cultivated companion. It has been called names that frightened adults and graced advertisements that sell imagined tropical ease. It has been the subject of scientific study and the foundation of livelihoods across continents. The untold parts of that story are not only the distant voyages encoded in DNA, but the contemporary choices we make about who benefits from the palm's products and how its groves will be stewarded in a warming, changing world. Policies that support smallholder processing, that protect land rights, that invest in resilient varieties and integrated coastal management, all change how the next chapter will read. So too do consumer choices, demanding traceability, fair payment and sustainability, shape whether coconut cultivation becomes a path to shared prosperity or a renewed pattern of extraction. The coconut began its long conquest of the tropics by drifting on currents and by hitching a ride with human hands. Its shell holds more than meat and water. It preserves the imprint of human voyaging, trade, ritual, and labor. From the beach where Portuguese sailors laughed at a face in a nut to the lab benches where scientists decode lineage, from family groves planted at births to plantations that remade landscapes, the coconut's history is an archive of human ambition and adaptation. If this episode has shifted what you thought you knew about a familiar fruit, share a coconut fact or a personal memory in the comments below. Maybe a recipe, a childhood memory on a shoreline, or an observation about groves in your home region. These small stories are part of the same tapestry. And if you want more deep dives into the curious, overlooked histories woven through the things we take for granted, subscribe for future episodes. The coconut's journey is far from over. Its next chapters will be written by the fields we tend, the markets we support, and the policies we choose.